Dear students, today I'll discuss with you some important points from the chapter Chemical Energetics. So these are first work done. So there are two types of work done. One is work done on the system, other is work done by the system. Okay. So first work done on the system. Okay. So use the formula for both the systems. Work done by the system or work done on the system. Use the formula W is equal to minus integration PdV. Okay. So let us take for on the system. What happens? V2 is the final volume, V1 is the initial volume, and it is compression. Okay, it is compression. First say this is the volume. Okay, this is the volume V1, and V2 volume is this one. Okay, this is V2. So generally V2 minus V1, your delta V is negative. But if you take this formula, work done is equal to minus integration PdV, that means negative of negative is the positive. So on this system, work done on this system, it is positive. Okay. Why this is positive? Because internal energy increases. When you compress this, the internal energy of the system increases. Internal energy increases. Okay. Then work done by the system. What is work done by the system? By the means previous, it is the volume, a final volume, this is V1 and this is V2. This expansion. Okay, this is expansion. So V2 minus V1 is delta V is here positive, but minus sign is there. Before that minus sign is there. That is work done by the system is your what? Your negative. Work done by the system is negative. Okay. So what happens here? Because the internal energy of the system decreases. When you expand, the internal energy of the system decreases. Okay. So work done on the system, you are positive. Work done by the system, it is negative. Okay. Next, SI unit for heat and work, it is in joule. Okay. SI unit for both heat and work. For heat it is joule and work is also joule. So 1 joule is equal to 1 Newton into 1 meter. Okay, this is your force and this is distance. W is equal, this is W work, W is equal to F into S. Okay. So 1 calorie is equal to 4.184 joule. When there is need of conversion, you can do. That's 1 calorie is equal to 4.184 joule. And 1 joule is equal to 10 to the power 7 ergs. Next, for reversible isothermal compression, when there is a need of problem solving, for reversible isothermal compression, work done for compression is equal to 2.303 nRT log V2 by V1. Understand? Remember, for reversible work done compression, when there is a compression, 2.303 nRT log V2 by V4. V1. So volume is inversely proportional to pressure. So if you take pressure, then it will be log P1 by P2. Log P1 by P2. Okay. Okay, you can compare. You see here compression for reversible isothermal process, compression, you are taking positive. Same thing, compression, work done on the compression positive. Here is positive, here is also positive. Okay. For reversible isothermal expansion, it is negative, minus 2.303 nRT log V2 by V1 or minus 2.303 nRT log P1 by P2. Okay students? Yes. Next, relation between internal energy and work done from the concept of first law of thermodynamics. Okay. First law of thermodynamics, what is first law? Conservation of energy. Conservation of energy. First law of thermodynamics. First law of thermodynamics. It is conservation of energy. Okay, so here what is given? Delta E, that is internal change. Internal change is equal to Q, that is heat content. Q is the heat content, minus PWB, P delta V. Okay, so this is the, you can take Q plus work done. Q plus work done, that is delta is equal to Q plus work done. First law of thermodynamics. So for compression, delta is equal to Q plus work done. Okay, so previously what is the internal energy? The internal energy, let it be U1. Internal energy is U1. When you compress, it will gain energy. That gain energy is Q. So total energy E1 plus Q. Okay. When it is work done, you add this W. If work is done on the system, the gas further gains some components of energy. Listen, first it is the internal energy. E1 is the internal energy system. When you compress, it will gain energy Q. When work is done, then this work is also energy. So again in the final state, E2 is equal to E1 plus Q plus work done. Understand? Yes. So when you take E1 this side, left side, E2 minus U1, that is delta E, is equal to Q plus W. Understand? Yes. Next, for expansion, work done is done by the system. So E2 minus E1, initial internal energy of the final minus internal energy initial, let it be Q. Okay, so from this Q, some work is done, means you take some amount of energy and do the work, so it will decrease. So Q minus W. Okay, so E2 minus E1 is equal to Q minus W. So what is E2 minus E1? Delta E is equal to Q minus W. Okay, so this is for expansion. Then comes to second law of thermodynamics. What is second law of thermodynamics? It explains, the second law of thermodynamics explains spontaneity of a process and entropy. Spontaneity and entropy. Okay, so this is S. Spontaneity, entropy is S. Okay, so we already learned some Panda from the entropy. Okay, when entropy, that is positive entropy, it is more disorder. So positive, this is more disorder. Okay, that is the process is spontaneous. Okay, so you see, third law of thermodynamics, also known as Nernst law of thermodynamics. It is also known as Nernst law of thermodynamics. So at absolute zero, what is absolute zero? Minus 273 degrees centigrade is absolute zero. Minus 273 degrees centigrade is absolute zero. Okay, the entropy of this perfectly crystalline substance is taken as zero. Perfectly crystalline. That is, the atoms or molecules are said to be perfectly arranged. There is no disorderness. Therefore, the entropy is zero. Okay, so mathematically, limit T tends to 0, del of delta G by delta T at constant pressure, that is limit T tends to 0, delta S is 0 for crystalline. Okay, so limit del T tends to 0, del H by del T at constant pressure, limit T tends to 0, delta Cp is also 0. Okay, so at very low temperature, that is the temperature range 0 to 15 Kelvin, any pure substance can use the relation that is ST is equal to entropy is equal to integration of 0 to T Cp dt by T, okay, or 0 to T Cp d ln T, okay. So you can use this formula and do the problem solving, okay. Have a good day, students.